All right, so in any chemistry course, the one thing you're definitely going to have to start talking about is the atom. The atom is the fundamental building block of nature. Everything you've seen, everything you've touched is made up of atoms. The paper I'm writing on, the ink I'm using, the pen I'm using is made up of atoms. Even though we consider it the fundamental building block of nature, it's actually not fundamental itself, meaning that it is comprised of smaller fundamental units, which we refer to as subatomic particles. So if we took if we drew a very simple model of the atom, what we would find is that it contains a nucleus, a very small, dense region in it that contains two subatomic particles, the proton and the neutron. And flying around the outside, in what we're later going to refer to as orbitals, is the electron. The electron is negatively charged and very small in comparison in terms of mass to the nuclides, the subatomic particles that reside in the nucleus, the proton and the neutron. The proton is positively charged and the neutron is neutral, and hence sort of what gave it its name, a neutral charged subatomic particle, the neutron. Now, of course, these subatomic particles have some physical properties that we might want to mention in terms of mass and then, of course, charge. The proton, which, as you saw previously, I usually abbreviate as lowercase p with a positive superscript because it is positively charged. One thing that we could talk about is of the subatomic particles is the mass. If we look up the mass of a proton in kilograms, we find that it comes in at 1.67262 times 10 to the negative 27th. That is a very small mass, a very small number. That's because the subatomic particles are very, very small indeed, just like atoms. The neutron is actually slightly more massive. We usually abbreviate the neutron as lowercase n with a 0 in the superscript because it is neutral, doesn't have a charge. Its mass is 1.67493 times 10 to the negative 27. So it's still very, very small, but slightly higher than the proton. And the electron is actually less massive than both of them by a couple orders of magnitude. We usually abbreviate the electron E with the superscript negative, and its mass is 9.1 times 10 to the negative 31st kilograms. Now, as you can see, those are very, very small masses. And so another unit that we could use in terms of its mass is what's known as the atomic mass unit. So an AMU, something that we'll use very early on in this course, is an atomic mass unit. The atomic mass unit, the mass of the proton in AMUs, is 1.00727. So because the atomic mass unit is a lot smaller mass, in terms of size, it's a little bit more convenient to use AMUs when talking about subatomic particles and even atoms. The neutron, because it's a little bit more massive, comes in at 1.00866, and the electron comes in at 0.00055. Now, at some point in time, we might want to convert between kilograms and AMU, so we can look up the equality for that. And the equality comes in with the 1 AMU being equal to 1.66 times 10 to the negative 27th kilograms. All right, the other physical property that we are going to want to learn about the subatomic particles is the charges, the actual values of the charges for each subatomic particle. So the proton, which we previously said is positively charged, the measurement for charge is actually the coulomb, which is abbreviated capital C. The charge of a proton is positive 1.66 times 10 to the negative 19th coulombs. The electron is negative, but it actually has the exact same charge, 1.66 times 10 to the negative 19th coulombs, just negative. So that when an atom or molecule has the exact same number of protons and electrons, it is charge neutral. The neutron, as we previously said, was neutral, but we don't want to leave this out of this discussion, so we'll still use it. It has a 0 coulomb charge. That is the absolute measured charge of the proton and electron, but we also want to talk about this usually in just relative terms. So when we talk about the charge of the proton, usually we just refer to it as a +1, and the electron as having a -1 charge. And of course that's relative. The actual measured charge is the coulombs. And the neutron still comes in at 0 for a charge.